All right, this question number 9 from the Unit 2 review. This time it says find rational and irrational zeros. So there might be numbers that we get some ugly decimals, and that happens sometimes. So again, let's do the P's and Q's. So this is P, this is Q. We're listing out the possible rational zeros that might work. Okay? And again, it's always P over Q. Let's change that color up. It's P over Q. And I'm looking for factors of 6. And this time I have a few options. So it's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then factors of 3, plus or minus 1, or plus or minus 3. Okay, because we don't know if our signs are positive, negative, or if they're flipped. And this is just a shortened way to write it all out. Now I'm going to make as many fractions as humanly possible. Okay, I'm going to go ahead, like, for example, 1 over 1 is a fraction. 1 over 3 is a fraction. 2 over 1 is a fraction. 2 over 3 is a fraction. 3 over 1 is a fraction. You'll notice 3 over 3 is the same as 1, so I don't need to write it down twice. And then 6 over 1, vice versa, 6 over 3. So I'm going to list those all out. So my potential zeros are plus or minus 1, plus or minus 1/3. Okay, and I'm just doing all the numbers that have a 1 in the numerator. I've got plus or minus 2, plus or minus 2/3. I've got plus or minus 3. And again, when I do 3 over 3 here, I'm not going to count this one because I know 3 divided by 3 is 1, and I already have that up here on my list. And then I'm going to do all the ones that lead with 6. So we got plus or minus 6, and I'm done. And also, 6 divided by 3 here is 2, and I've already have that in my list as well, so no need to repeat. Okay, again, we're going to cheat and use our calculator. So I've already typed this function into my calculator. And when I look at the table here, I notice that 3 has a y value of 0. And that means 3 should work with our synthetic division. So I'm going to go ahead and type 3 into the box here. And then I'll go ahead and bring down all of my numbers with the variables called the coefficients and my constant here at the end. And then I'll do synthetic division. It's an awesome little trick here for breaking up a polynomial. First number drops straight down, and you'll remember that we always multiply the bottom row by what's in the box to get the next number. So right here, I would get 9. And I add down in vertical columns. I get 11. Multiply 11 by 3, and I get 33. Color here. Okay, I add down in vertical columns, I get negative 2. And last but not least, I get negative 6. And I know I'm on the right track because I get what's called a remainder of 0 here. All right, in factored form so far, f of x equals x minus 3. I get this first binomial by the 0 I already know that works in my calculator. And then I'm going to turn this into a trinomial here. I'm talking about these three terms, 3x squared plus 11x minus 2. And then I would try to factor this. And through trial and error, I would try a bunch of different options, but I don't have too many options. Like, I know it's got to be 3x and x. I know my signs have to be different. And I know my numbers on the last terms have to multiply to a negative 2. So it's my options are 2 and 1 or 1 and 2. I really don't have that many choices. And when I do outers and inners, you know, like that's 2x, that's negative 3x, that doesn't work. If I swap the 2 and the 1 here, and I put 1 here and 2 here, I get 1x here, I get negative 6x, not even close to positive 11. So I could keep trying and trying and trying, and I would notice this doesn't work, and I would say not factorable. Now, just because it's not factorable does not mean I can't find the zeros. Now, in factored form, this is as factored as it can get. I would just say x minus 3, and then I would leave this trinomial here. And I'm done with that part. Nothing more I can do to break that down. Okay, so here's part of my answer. All right, I'm going to work up above here. I can break down this 3x squared plus 11x minus 2 by using the quadratic formula, where this is a, this is b, and this is c. Let me go ahead and pull up the quadratic formula real quick. All right, it looks like that, and I just slowly but surely plug the appropriate number in the appropriate spot. So it's negative 11 plus n minus the square root of 11 squared minus 4 times 3 times negative 2. All divided by 2 times 3. All right, I'm going to clean this up a little bit. What I like to do is I like to turn all of this into one number, which makes life a lot easier. And when I do the math there, 11 squared minus 4 times 3 times negative 2, I get the square root of 145. This is negative 11. And then we can do the simple math, multiply it like this. Now, I can leave this as my answer here. There's ways of simplifying that radical, but I'm not super concerned about that. And if I wanted an exact answer, I would get something that looks like this. So my zeros would be, I know 3 works, comma, and then I know negative 11 plus the square root of 145 divided by 6 is going to give me 1 0. And I know a negative 11 minus the square root of 145 divided by 6 is going to give me a 0. And if I want more exact answers, I would type these into the calculator and see what I get for decimals. And I'll do that real quick. So I'll turn my calculator on, get out of the screen, clear. So I'm going to go negative 11 plus square root of 145. And I like to hit enter, divide by 6. There's one of my zeros. So point, I'll say 17 roughly. And then I do the same thing, but instead of adding, I now subtract. Minus, enter, divide by 6, enter. And there's my other 0. Negative, I'll put 0.17. And then negative 3.84. And these are, again, not pretty answers, but they are exact. And so these are the zeros I'm looking for. This is a more appropriate answer. I would accept either one of those decimal or radical form.